Namaskar. So, yesterday we discussed about mesh analysis and we also discussed that how the mesh analysis would be done if current source is available. Current source may be the independent or dependent. So, that particular aspect we discussed in yesterday's class. So, today we will discuss about the nodal analysis. So, let us see what do you mean by nodal analysis? Actually, nodal analysis provides a procedure for analyzing circuit using node voltage. So, in the mesh analysis we were more concerned about the mesh current and we were utilizing mesh current to solve the circuit. Here we will use node voltage as a circuit variable to solve the circuit. Now, node is the network node of a network is defined as a point where two or more branches are joined. So, if you see this particular figure, in this figure you will see 1, 2, 3, 4, 5 are the total nodes. Now, if you see for this particular node called node 4, you are joining the impedance ZA and the voltage source Vx. Similarly, in node 1 you are joining ZD as a impedance and ZA as an impedance and ZB as an impedance. So, node 1 has 3 connections. Similarly, node 2 also have 3 connections, that is ZB, ZE, ZC. Node 5 will have only 2 connections, that is ZC and VY. Out of all those nodes, one node is considered as a reference node, that is node 3. So, now this node is different from this node in the sense that this node contains at least 3 branches and this node contains only 2 branches. So, what we will call this particular node? This particular node would be called as a principal node and rest of the other nodes would be called as a simple node. So, what are the principal node in this particular circuit? So, in this particular circuit principal node would be node 1, node 2 and node 3, while node 4 and node 5 are the simple nodes. So, let us see what is the significance of the principal nodes. What is the node voltage? Node voltage is the voltage of a particular node with respect to another node which is called as a reference node. So, what we can see from this figure, if you say this as a V1 3, that means that V1 voltage with reference to reference node number 3. Similarly, here you can write as a V2 3, here you can write V4 3, here you can write V5 3. So, these would be the nodes node voltages with respect to the reference node, that is node 3 in our particular case. Now, what we have to do? We have to only take those nodes which are principal nodes into consideration and the voltages which we assign to those nodes would be the circuit variables for nodal analysis. So, if you see in this particular figure, V43, V13, V23 and V53 are the 4 node voltages. Node 3 will always be at 0 potential because we consider it as a reference. So, with respect to this node all would be considered. So, node 4, node 5 are the simple nodes, while node 1 and node 2 are principal nodes. So, in circuit analysis using nodal analysis, we are more concerned about the voltages at principal node. So, we have seen that the node 3 we have chosen as a reference node. Now, we have seen that we are mentioning V13 and V23, that is the voltages at principal node 1 and 2, with respect to node 3. Now, since we know that node 3 is the reference node, so what we can do for simplicity, we can write V1 as in place of V1 3 and V2 in place of V2 3, because we know that this is always be with reference to reference node. So, for simplicity, instead of V1 3 we can simply write as V1, and for V2 3 we simply write as V2. So, V1 and V2 would be the node variables. Basically, we can say it as a circuit variable for this particular circuit. Now, what is the overall objective of our nodal analysis? The nodal analysis objective is to determine the values of voltages at all the principal nodes, that is with reference to with respect to reference node. So, in this case the objective is to find the voltages of V1 and V2. When we get these values V1 and V2, we can determine the currents flowing in each branch. So, that means if you see this particular circuit, if you are able to find the value of V1 and V2, you can simply find out the value of V4. So, here V4 3 can be written as V4 and V5 can be V5 3 can be written as V5. So, when we know the value of V1 and V2, we can find the value of V4, because that is simply V1 minus Vx, and for V5 also, if we know the value of V2, we can find the value of V5, that is V2 minus V2. Here it will be plus V5, because the direction of voltage is from minus to plus. So, V5 would be V2 plus Vy. So, when we get these node voltages, you can easily find out the value of currents using Ohm's law. So, now you can summarize that what would be the steps to determine the node voltages. First, you have to select a node as the reference node, then assign voltages say V1, V2, Vn to the remaining n minus 1 nodes. The voltages are referenced with respect to the reference node. Now, you have to take n minus 1 non reference nodes, that is the nodes which are other than the reference nodes, and you have to apply Kirchhoff current law and use Ohm's law to express the branch currents in terms of node voltages. So, here you can write equations for all the non reference nodes, but while analyzing the circuit you would be more concerned about the equations you write for principal nodes, because the equations which you write for principal node would be solved first, then you can find the value of other non reference nodes voltage value. Now, you have to solve the resulting simultaneous equations to obtain the unknown node voltages. So, these would be the three major steps which you will follow when you have to find the node voltages. Now, how we will carry on this particular operation? Let us assume that this is the circuit which we saw previously, and we will apply the nodal analysis and try to find out the values of node voltages V1 and V2, and then accordingly you can find the voltages and currents for say that is V5 and V4 and the currents flowing in the branches. Now, let us take the first node, that is node 1. Now, if you see node 1, you can assume that all branch current which are leaving the node, you will assume that all branch currents are leaving the node. So, as per Kirchhoff current law, your sum of the currents at that junction would be 0. So what you can say? You can say these are the three currents. You can write maybe I1, I2 and I3. So what will happen? Your I1 plus I2 plus I3 would be equal to 0. Now you have applied KCL. Now you have to put the value of I1, I2 and I3. What is the value of I1? I1 value would be the voltage difference between V1 and V4 divided by ZA. So what is the voltage of V4? V4 is nothing but Vx, because the Vx is connected between the node 4 and node 3. So what you can write for I1? I1 you can write V1 minus Vx divided by ZA, plus for I2 what you can write? I2 is simply the voltage node voltage V1 divided by the impedance connected between 1 and the reference node, plus current I3. I3 would be V1 minus V2 divided by the impedance ZB, and that would be equal to 0. So this is what you will get in case of node 1. Similarly, for node 2 what you can write? You can assume that in this case also the current is like this. You can say it is I4, I5 or I6. Here I4 is nothing but minus of I3, but let us assume that the I4 is different and it is coming out of node 2. So what you can write? I4 plus I5 plus I6 is equal to 0. I4 value you can simply put V2 minus V1 by ZB, plus I5 is nothing but V2 by ZE, plus I6 would be, now Vy is connected between node 5 and node 3, and the direction of V is like this because it is mentioned in this figure like this. So what will happen? Here you can write V2 minus of minus Vy divided by ZC, that would be current I6, okay, and then it will be equal to 0. So what eventually you will get? You will eventually get the same equation which is mentioned in this slide. So you will get these values. Now what you can do? You can rearrange all the variables, like V1 you can put together, V2 you can take together, and then Vx and Vy in both of the equations. Now if you know the values of ZA, ZB, ZD, ZC, ZE, so you can simply put the value, it will be very simple equation. Sometimes it is difficult to write in this form. What you can alternatively do? You can convert impedance into admittance, that is YA. YA is nothing but 1 by ZA. Similarly, YB is 1 by ZB and YD 1 by ZD. So what you can write now? You can simply write the equation in the form of admittances, and now you have simpler equations. You can solve it for unknown variables which are V1 and V2. So you have two unknown variables and two equations which can be easily solved. So the current equations and hence the voltage equations may be written at each principal node of a network with exception of reference node. So you have written for principal node 1 and 2, and you need not to write any equation for reference node. So you got two equations. Now the number of equations necessary to produce a solution for a circuit is in fact always one less than the number of principal nodes. So in this figure the principal nodes were 3, 1, 2 and 3. So number of equations required would be 3 minus 1. So, you need two equations to solve the circuit and you got these two equations. So, with this equation creation you can solve the circuits which are having node voltages as a variable. So, let us take an example so that you can understand the concept clearly. For the network shown in the figure below, we need to determine the voltage VAB. So, voltage VAB means VA minus VB. So, if you take B as a reference node, then its potential can be at 0 degree. So, at 0 volt, and voltage VAB is nothing but simply voltage at node A. So, how you will solve? You have to again find out the principal nodes. So, what are the principal nodes? The principal nodes here are 1 and B, because these are the only two nodes where number of branches connected are 3. So, you have got principal nodes. Now, out of that only one nodal equation is required, because you have taken B as a reference node. So, you need to write only one equation to solve the voltage at node 1, that is V1. So, if you apply Kirchhoff's current law at node 1, what will happen? This current is IY, this is IX, and this current is I. So, if you write I is going in, IX and IY are coming out. So, I would be equal to IX plus IY. Now, what you have to do? You have to write the values of currents in terms of node voltages. So, for IX, what is the value? That is basically the node you have already taken as a reference node. So, the IX would be V1 divided by the 16 ohm resistance. So, V1 by 16 is IX. Similarly, for IY, what you can write? You can write V1 divided by the impedance of the complete branch. So, what is the impedance now? This is resistance. So, this is 4, this is inductance. So, you can just simply write J3. So, what would be the current IY? It will be V1 upon 4 plus J3, and this will be equal to the current value which is given in the example. So, now what you have to do? You have to just simply solve it, because here you have only one unknown and you have got one equation to solve it. You simply take V1 out and solve it. You will get the value of V1 as 79.1 with angle 28.34 degree. So, you got the value of V1, but your objective is to find the value of VA. So, what you will do? You have to first find out the value of current IY, that is nothing but V1 upon 4 plus J3, because IY is nothing but V1 upon 4 plus J3. Now, we have to see what is the drop in this particular segment, that is between A and B. So, what you will do? You will use Ohm's law, and whatever the current is flowing, that is IY, and multiplied by the resistance 4 would be the voltage at node A. So, what will be VAB? IY into 4, that is the resistance. So, you will simply put the value of IY, that is V1 upon 4 plus J3. V1 you have just found, that is 79.1 with angle 28.34 degree, then divided by 4 plus J3, that also you can convert into the phasor form, because it is easier to calculate, and when you simplify you will get the value of VAB as 63.3 and angle is minus 8.53, because 28.34 minus 36.87 will give you minus 8.53 volt degree angle for the voltage at node A. So, this you can easily solve and find out the value. Next, let us take another example. If you are asked to use nodal analysis to determine the current flowing in each branch of the network, which is shown in this figure. So, what you can see from here, there are two principal nodes, that is node 1 and node 2. Node 2 you can take it as a reference node. So, you need to first find out the value of V1. When you find the value of V1, you can simply find the values of current, that is I1, I2 and I3. Here I1, I2, I3 all three have taken out of the node 1. So, you can simply write I1 plus I2 plus I3 equal to 0. Now, you have to put the value of I1, I2 and I3. What is I1? I1 would be V1 minus 100 angle 0 divided by the 25 ohm resistance. So, you got the value for I1. Similarly, what is the I2? You get V1 divided by 20 ohm, because reference voltage is 0. So, that you got I2 is nothing but V1 by 20. Now, what is I3? I3 is, in this case, would be V1 minus the voltage divided by 10 ohm. So, that becomes now V1 minus 50 angle 90 degree divided by 10, and then I1 plus I2 plus I3 would be equal to 0. Now, if you solve, what you will get? You will get the value of V1 as 4 plus J5 divided by 0.19, and if you simplify, you will get the value of V1 as 33.7 and angle 51.34. So, you have got the value of V1. Simply you have to put the values of V1 in I1, I2 and I3, and when you will put the value, you will get the values of currents, right. So, in this way you can easily find out the value of currents. So, those are the branch currents in this case, and you can solve the circuit. Now, let us take another example. In this case, the node voltage needs to be determined, but here the source is, one is independent current source and second is the dependent current source. So, in this case, when you have dependent and independent current source, how you will solve the circuits? You will follow the same procedure what we did in the previous example. You have to first find out the principal nodes. So, what are the principal nodes in this case? In this case, this would be principal node, because here 1, 2 and 3 branches are joining. 2 is also principal node, because all 3 resistances are connected here. Node 3 is also principal node, because 2 resistances and 1 dependent current source is connected, and 0 is anyway principal node, but this is a reference node. So, we have considered this as a reference node, and now we will try to solve the circuit. What you will get from node 1? In case of node 1, the value of current, say this is Ix, this is I, and this you may take another value as I1. So, what will happen? That you can simply write that 3 ampere current is going in and I1 and Ix are going out. So, you will write as I1 plus Ix. Now, you have written this value in terms of current, convert them in terms of voltage. So, what you will do? You have assigned the value of node voltages as V1, V2 and V3. That means you need 3 equations to solve, because you have now 3 unknowns V1, V2 and V3. So, when you write current I1 in terms of the voltages V1, what you can write? V1 minus V3 divided by 4, and for Ix you can write V1 minus V2 divided by 2. So, one equation which you got is 3 V1 minus 2 V2 minus V3 is equal to 12. So, this is the equation you got while applying KCL at node 1. Similarly, for node 2 you can write Ix is going in and I2 and I3 are going out. So, Ix would be equal to I2 plus I3. What is Ix? Ix is nothing but V1 minus V2 by 2, I2 is nothing but V2 minus V3 by 8, and I3 would be V2 by 4. So, when you solve, you get another equation in terms of V1, V2, V3. Similarly, for node 3, if you write in this case node 3 would be I2 plus I1 plus, since it is in downward direction. So, you can write this is going out, these two are going in the node. So, you can write 2 Ix is equal to I1 plus I2, right. Now, what is the value of Ix? Ix you have calculated as V1 minus V2 by 2. So, you will just place the value of Ix in this dependent current source. So, you will get the value of 2 Ix is nothing but 2 into V1 minus V2 by 2, and then simply I1 is nothing but V1 minus V3 by 4, and I2 is V2 minus V3 by 8, right. So, you got another equation from node 3. Now, you have 3 unknowns V1, V2 and V3, and you have got 3 equations, that is 3 V1 minus 2 V2 minus V3 equal to 12, and minus 4 V1 plus 7 V2 minus V3 is equal to 0, and 2 V1 minus 3 V2 plus V3 equal to 0. So, now you have 3 equations, 3 unknown. If you solve all those 3 equations, you will get the simply the value of V1, V2 and V3. So, the node voltages which were asked to determine have been calculated in this way. So, with this way you can solve any type of equation, any type of circuit network with the help of nodal analysis. So, in this particular week we discussed about node voltage, nodal analysis and mesh analysis. So, whenever you see that you need to find out the circuit parameters in terms of currents, you can use mesh analysis, and when you are asked to find out the node voltages, you can use nodal analysis. So, if you compare both of the analysis, you will come to know that mesh analysis is depending upon Kirchhoff voltage law and nodal analysis is depending upon Kirchhoff current law. But sometimes in both of the cases you might need both of the Kirchhoff laws, that is voltage law as well as current law, to solve the circuit. So, with this we will close today's session. In next week we will discuss about the various network theorems. Thank you.